This lesson is a little bit of review, then some word problems. And I should say with the review, some of the stuff we didn't quite get to, so it's not really a review. The other stuff is stuff that we kind of know how to do, but it's a lot of different things all in one, and we haven't done all the things in one problem yet. So they might look a little bit new, but some of them, again, the stuff we've done before, but just all together. So the objective, the main thing, students will increase the capability of doing story problems with proportions. So this first one, we want to find the missing measurements. Now, before we do anything, since these triangles are similar, that means that all sides are proportional. We know that. We talked about that a lot. That's where we cross multiply. We've done this. However, the thing we haven't talked, or we mentioned, but we haven't really stressed, we haven't talked about it a bunch. All the sides are proportional, but all the angles are congruent. Now again, I did say that, and it was written down in the notes, it was on your paper, but we don't say that all the time. We don't say that as much as the sides. So a lot of people forget that. So make sure you remember that. And the main reason I say that is because to solve this x, we have to realize that the angles are congruent. Now, to find the angles, we are going to do the triangle sum theorem, where if you add the angles in a triangle, they have to add up to be 180. But the problem is, I don't know this angle x, and I don't know this angle up here. Well, again, if the triangles are similar, then those angles have to be congruent. So that means this W angle is congruent to this N angle down here. So that's 58 degrees. So now we add those three together, x plus 58 plus 39. That has to add up to be 180, and now we can solve for that. So 58 plus 39, combine your like terms. X plus 97 is equal to 180. Subtract 97, we get x is equal to 180 minus 97 is 83. So that means this angle over here is 83 degrees. Now again, that means that this angle V, if you look up here, pairs up with angle M. That means this is 83 degrees, and this one would be 39 degrees. And again, you can kind of see they look like they're congruent, but you can also use your similarity statement to be sure. So now we're going to solve for y. I'm going to erase this. You don't have to erase yours, obviously, but just since I don't have, just to make it a little bit more clean, so you guys don't get confused, now we're solving for y. Well, now we're dealing with the sides, so we have to remember that the sides are proportional. So if you can't tell, we have LM is similar to VU. So VU and LM, if you can't tell, again, the similarity statement kind of tells us. It doesn't matter which one you put on top as long as you're consistent. So I'm going to put the small on top, the big on bottom. So 18 over 45 is equal to, the small one is 15 over y. Now again, if you can't tell if this 15 corresponds with LN or MN, just look at your similarity statement. So your similarity statement up here, 15 is WU, and so it has to go with NL, so that's got to be this one, which is the Y. So now we just cross multiply. We have 18 times Y is equal to 45 times 15. 18y is equal to 45 times 15 is 675. Divide both sides by 18. We get y is equal to 37.5. And you can leave that a decimal. If you want to make it into a fraction, you can. It's all your call. I'm just going to leave it as a decimal. So the next one. So it tells us these triangles are similar. Now the triangles, just to make sure, we have this smaller triangle, and then we also have this bigger triangle. So to find out what this angle x is, again, we need to find out what this angle is. So we have 92 and 41. So again, to make it so we can see it a little bit better, 92 plus 41 plus x is equal to 180. And that's this x I'm talking about. Again, they're congruent, so you can call them both x if you'd rather. 92 plus 41 is 133. Minus 133 is equal to 47. So your x is 47 degrees. Now, again, I'm going to erase this just so I can see it a little bit better. Now we're going to talk about the sides. Now this one, you have to make sure you look a little bit closer because this side length is 8, but we're not pairing that up with 12. It's the whole length that we're comparing it to, because we're pairing this length of your small triangle to this length in your big triangle. Well, if we have 8 and 12, that makes this length 20. So that's one of those things, again, I didn't really talk about that specifically, but it's not too bad as long as you're making sure you're being careful. But I did want to make sure I went over that. So again, I'm going to put my small on top, my big on bottom. I like to do it that way. So my small one is 8 over the whole thing, 20, not 12, the whole thing is equal to. Then the other side, the small one is 16 over y. And again, that y, this one, we don't have to do anything because they're labeling the whole thing as y, not just this little part. Just should make sure that doesn't confuse anyone. So cross multiply, 20 times 16 is equal to 8 times y. 20 times 16 is 320, equal to 8 times y. Divide both sides by 8. You end up getting y is equal to 40. So I forgot to put this one in here, and I wanted to add this. Now, this problem may or may not show up on a test or a quiz, and it's really not that bad. Again, we just haven't really gone over specifically. So what they're saying, if we have 1 over 5 is equal to x over y, then what is 1 over x equal to 5 over what? Now, the thing I want to make sure you realize is that this one, any number, but any number has a relationship with the number below it and the number straight across from it. So it doesn't matter what number you pick, it's got the relationship with both of those. So if I pick y, it's got a relationship with 5 and a relationship with x. It's got to be in those same, it's got that relationship, so they got to be close to each other. They've got to be in the relative position. So it doesn't matter whether you put the 5 on top, and then that means you have to put the y on top. You can do that. Or you can also write this a different way. Now, the other way is to make, remember I said 1 and 5 have a relationship, but so do 1 and x. So that's how they made this fraction here. They put 1 over x. Well, then the next fraction then, if the 1 went on top, the x went on bottom, then the 5 has to be with the y, so this question mark has to be a y. And again, if you look, it has that same relationship. 1 goes with x and with 5. Y goes with x and with 5. So that's the other way to look at this. And again, don't make it harder than it is. They're literally just kind of putting it on its side. 1 over x, 5 over y. Now again, there's several other ways to write it or to think about it, but that's the way you've got to find, that's the answer you get, depending on, again, I guess I should say it doesn't matter how you get that answer. There's a couple different ways to think about it and a couple different ways they will write it, but it should all lead you to the same thing. So this one's the same type of thing. The only difference is now they are saying we have x over 8 and 9 over y. Well, now they're saying now the y is over 9, which means over here the 8 just has to go on top, 8 over x. So again, that's a little bit different. Now again, if we wanted to, we could also say x over 9 is equal to 8 over y. We could also say 8 over y is equal to 9 over x, or what was the other one? Oh, I could do 9 over x is equal to y over 8. It all is the same because we have that relationship. 9 goes with y, 9 goes with x, 9y, 9x. All those are the same. All those are similar. You just have to make sure you're comparing how they're writing that first fraction, and that's going to tell you how they write that second one. If you get confused on that, I'm willing to bet you're thinking about it too hard and making it harder than it actually is. Just look at the relationship. Again, like I said, look at the relationship of that first fraction. Even if we go back to the last one, the last fraction was 1 over x, and my 1 and x were right here, so that means the 5 and y have to go together. Again, if I would have put y over 5 is equal to what? Well, the y and the 5 go together, so then we have 1 and x, and the x is on top this time. Okay. So assuming the figures are similar, solve for x. So since these are similar, we have 84 over 6x minus 2 is equal to 98, since those are in the same fraction. And again, you can write these fractions several different ways. That's what those last problems were telling you. But I think it's a lot easier if you stick to that, where we have one triangle's on top, one triangle's on bottom. Either label it big and small, whatever you need. You don't have to label it, but as long as you're consistent, I think that's the biggest thing. So we cross multiply. We have 84 times 60 is equal to 98 times 6x minus 2. 84 times 60 is 5,040. Make sure you distribute that to both of them. A lot of people forget that too. 588x minus 98 times negative 2, 196. And again, now you just solve this one. So add 196. Oops, it's supposed to be a 5. Divide both sides by 588. You end up with 8.90. I always like to round to 2 decimal places unless I tell you otherwise. Just to make sure, 84 over that. .84 times 60 is 540. 98 times 6. 98 times 2. Yeah, so everything checks out. I like to double check if I get a decimal or fraction, but it happens sometimes, so that is the answer. Now this next one is something that there's actually a whole theorem I'm not going to teach you, but it's called the side splitter theorem. But the first thing is that all 3 of these sides are parallel, and really it's an easy problem. All they're saying, all the theorem says, I guess not directly, but you can get this from the theorem, that you can just set up proportions with these sides. So I always just do this one over this one is equal to this one over this one. So my x over 8 is equal to 28 over 16. Again, there's several other ways to do that. You could do x over 28 is equal to 8 over 16. So this one over this one, this one over this one. Doesn't make any difference. When you cross multiply, you're going to get the same answer. So whatever you want to do, x times 16, apologies, is equal to 8 times 28. That ends up giving you x is equal to 14. And this last one, it's similar to what we just talked about. The good news is they give you the whole length for this one, so you don't have to add or do anything like that. So again, I'm going to do small over big is equal to small over big, the whole thing, 63. And again, just make sure you realize you're looking at 2 different triangles. You're looking at this small triangle, and then you're looking at this big triangle. So we have 55 times 63 is equal to 99 times 3x plus 5. 55 times 63 is 3465 is equal to 99 times 3, 297x. 99 times 5. Now, we've gotten a couple big numbers with this stuff, but don't be intimidated by it because you just use your calculator. I know they're big, but if I made you do these by hand, that would be really intimidating, but just typing in your calculator, 3465 minus 495 divided by 297. We end up with x is equal to 10. All right, moving on. So now we're going to start getting into the word problems. Again, the biggest thing is making sure you set up your fractions, and the hardest part of these word problems, honestly, is making sure you set up your fractions correctly. There are several different ways to put your fraction, just like we said with those other examples earlier. But I would do it the way I'm telling you because I think that's the easiest way to comprehend it. Now, again, if you like a better way, you're more than welcome to. So a building casts a shadow that's 50 feet long. A flagpole that is 40 feet high casts a shadow that's 6 foot long. How tall is the building? So we can use this proportion. We have a flagpole, its shadow is 6 foot. The building, the shadow is 50 foot. We know the flagpole is 40 foot high, but how tall is the building? Well, that's you're going to set up the proportion. Now, again, you can do it however you want, but I'm going to do it this way, small over big, or you could do flag over building. And again, you don't have to label it, but I think that's a nice way to do it, to realize, okay, so I'm going to do the height of the flag is 40, and then the height of the building we don't know. And then the length of the shadow for the flag is 6 over the length of the shadow for the building is 50. So all my flag information is on top, all my building information is on bottom. Again, there's several other ways you can set that up. I just like that way because I think it's easiest to keep it organized. 40 times 50 is 200. Sorry, 2,000. I'm going to say I thought maybe I did that wrong. That divided by 6 is 333.33. Again, please round to 2 decimal places and make sure you're rounding. If you don't round, I'm going to count some points off. So that one is 333.33. Now we have another one. Erin, who is 1.6 meters tall, casts a shadow that is 1.25 meters. Her shadow extends to the end of a tree, and the shadow, she stands 4.75 meters from the tree. What's the height of the tree? So the biggest thing that's different with this one is they don't tell you the whole length of the tree's shadow. They just tell you that she's standing 4.75 meters from the tree, and her shadow is 1.25 meters long. So we have to add those together, 4.75 plus 1.25. To get the length of the whole shadow of the tree is 6. So they're asking the height of the tree. Again, we have Erin on top, tree on bottom. You don't have to do it this way, but I think this is the easiest. So let's talk about the shadows. We have Erin is 1.25 over the tree shadow is 6, because remember, it's both of those lengths, is equal to Erin's height is 1.6 meters, and the tree height we don't know. That's our x. So when we cross multiply, 6 times 1.6 is 9.6, divided by 1.25, x is equal to 7.68. Technically, that'd be meters, but I'm not going to be too finicky about labels. More shadow ones. If they don't give you a picture, I would draw one. So a tree that is 24 foot tall casts a shadow that's 12 foot long. Brad is 6 feet tall. How long is his shadow? So again, we're going to do Brad and tree. So Brad is 6 foot tall, and the tree is 24 foot tall. Brad's shadow, we don't know how long that shadow is, but the tree's shadow is 12. Now we cross multiply. 6 times 12 is equal to 24x. 6 times 12 is 72. Divide both sides by 24. You end up with your x is equal to 3. So again, that means the shadow is 3 feet long. Let's see, so another one, tower casts a shadow 7 meters long. So we have a tower. A vertical stick casts a shadow that's 0.6 meters long and 1.2 meters high. How tall is the tower? Again, so we have our stick and we have our tower. Our stick is 1.2 tall. We don't know how tall the tower is. The shadow for the stick is 0.6. The shadow for the tower is 7. So again, cross multiply. 1.2 times 7 is equal to 0.6 times x. 8.4 is equal to 0.6x divided by 0.6. With 14 is equal to x. Number 10, Mr. Kirkton is trying to figure out how tall the school is. If he is 6 feet tall and his shadow is 4 feet long, how tall is the building if he has a shadow that is 30 foot long, or if it has a shadow? So this is actually a good way you could do this. If you know how tall you are, it's easier to measure shadows than it is the building because you don't need like a ladder. But again, draw a picture. The building has a shadow of 30 feet. We don't know how tall it is. Mr. Kirkton is 6 feet tall and his shadow is 4 feet long. So we have Kirkton and the building. So it's 6 feet tall. We don't know how tall the building is. The shadow is 4 feet long for Kirkton and 30 feet for the building. 6 times 30 plus 4. Oh, sorry, equal to 4x. My apologies. 6 times 30 is 180 is equal to 4x divided by 4. X is equal to 45. The ratio of rectangles length to width is 4 to 7. The perimeter is 330. Find the length and the width. So we've done problems like this, but I want to make sure we do these because, again, they're not that bad if you know what to look for. So the ratio of the length to the width is 4 to 7. So it's going to be 4x to 7x. The perimeter is 330. Well, the perimeter is when we add all these together. So I know this side is 4x and this side is 7x. There's a shorter way to do this, but I think it's a little bit harder to remember. But we can just add those all together. That has to add up to be the, sorry, that's the perimeter of the whole thing. So now we combine our like terms. 4 plus 4 plus 7 plus 7 is 22. Divide both sides by 22. Is 15. So since what's the length and the width? Well, we found 15. We now need to plug that back in. 4 times 15 is 60. And 7 times 15 is 105. So that is the length and the width. Again, the way you can tell the difference is because whatever order they put it in here is the same order here. So length comes first, so the 4 goes with the length. Width comes second, so the width comes second. So one thing to tell easily is that your width is shorter than your length. Because the length goes with the 4, the width goes with the 7. So this is similar. We haven't done one like this, but this is similar to the last one. It just is with a triangle. So we have a triangle here. It says the ratio of the sides is 2 to 3 to 5. So we do the same thing. We just have 3 sides. So 2, 3, 5, and then all x's, 2x, 3x, 5x. Same thing with the rectangle. Then same thing, 2x plus 3x plus 5x have to add up to be the perimeter, which is 150. That ends up, if you combine like terms, 10x is equal to 150. Divide both sides by 10, we get x is equal to 15. Again, same thing with a rectangle. It's just a little bit different because it only has 3 sides, but they give you the ratio with the 3rd side, so you can figure that out. So we've done some shadow problems, then we did some of these perimeter problems. I want to make sure we did some of those. And now we're going to go into just other proportion problems with other things. Recipe for spaghetti sauce requires 5 bottles of ketchup to make 2 gallons of sauce. How many bottles of ketchup are needed to make 12 gallons of sauce? We could do bottles on top and gallons on bottom. So we have 5 bottles makes 2 gallons. How many bottles to make 12 gallons? Well, now we cross multiply. 2x is equal to 5 times 12. 2x is equal to 60. Yeah. Divide by 2. X is equal to 30. So you need 30 bottles. Totsakin, I don't know what that is or who that is, enlarged the size of a photo to a height of 18 inches. What is the new width if it was originally 2 inches tall and 1 inch wide? So let's look at the original. It's 2 tall, 1 inch wide. 2 inches tall, 1 inch wide. The new photo, that's obviously bigger than that, has a height of 18. So 18 goes with 2. So what's the width? Well, again, small and big if you want to. So my small one is 2 is the height. The big one's 18. And then the next one, my small one is 1 with the width, which means x for the other one. So 18 times 1, 2 times x. We end up getting 9 is equal to x. A frame is 9 inches wide, 6 inches tall. If it is reduced to a width of 3 inches, then how tall will it be? So again, draw another picture. 9 inches wide, 6 inches tall. If it is reduced to a width of 3 inches, then how tall is it? So we have 3 over 9 is equal to x over 6. Solve for x. That's 3 times 6 is 18 is equal to 9 times x. 2 is equal to x. If 3 apples cost $1.50, how much would 5 apples cost? So this happens all the time in the store where you can either get 3 apples for $1.50 or you can get 5 apples and you want to know which one's cheaper, buying less or more. Well, again, there's several different ways you can set this up. I'm going to put the price on top and the apples on bottom. So we have $1.50 for 3 apples. For 5 apples, sorry, 5 goes in the denominator. For 5 apples, what is it going to be? Well, we have 5 times 150, and that is 7.5 is equal to 3x. Divide both sides by 3. We get x is equal to 2.5. So it would be for 5 apples, it would be $2.50. Again, honestly, if you left it as 2.5, I could live with that. Next one, a rectangle has a length of 4 feet, a perimeter of 14 feet. What is the perimeter of the rectangle? It's with a width of 9 feet. So now they're asking a little bit different. Now they're asking for the perimeter. They're not giving us the perimeter. So a rectangle has a length of 4 feet. Oh, and the perimeter then, okay, so it's a 2-part. So the perimeter for this one is 14. So we're going to have to find out what this other side is maybe. And this one, oh, I see what they're doing here. Has a width of, sorry, a width. So this one is 9, and we don't know what the perimeter is. Okay, so the way we're going to do this one, which is a little bit interesting, is the first thing we're going to do is we're going to look at this smaller one. So we have, or this first one, I guess I should say. Maybe I don't know if it's smaller. So we have 4 feet, and the perimeter is 14. Well, if I don't know what this side is, I'm going to call that x for right now. So the perimeter is 4 plus x plus 4 plus x is equal to 14. So that's 8 plus 2x is equal to 14, and we can solve that one. 2x is equal to 6. X is equal to 3. Let's just double check. Okay. So this length is 3. So how does that help us here? Well, just double checking, make sure if they say certain things before I mention. With this one, we're assuming that they're similar. That's what I was looking for. They don't say that they're similar, but they should put that somewhere, that the rectangles are similar. Or else it could be something completely different. So since they're similar, we have 4 over 3, actually. And again, if you put 4 over 3, that's fine. I just like to stick to my small over my big, or vice versa. So 4 over x is equal to 3 over 9. So that's 3x is equal to 36. Divide both sides by 3, we get x is equal to 12. So now I know this one's 12. So now I can find the perimeter because that means this is 9 and this is 12. So you just add all those together. 9 plus 12 plus 9 plus 12 is 42. So the perimeter for that one's 42. So that one's a little bit of a harder problem. And I guess I should say it's not harder, it's just a little bit longer because we first have to try to figure out what this side is, kind of do that on its own. Then we're going to use that information with the similars to find out what this side is. And then once you have that, you can add everything together to get your perimeter. It's a good question. Chris wants to reduce a triangle pattern with sides 16, 16, 20. 16, 16, 20. If the longest side of the new pattern is to be 15, so the longest side instead of 20 is going to be 15, how long should the other two sides be? Well, it helps that the other two sides are the same, but they didn't have to be. 16 over x is equal to 20 over 15. So we have 16 times 15 is equal to 20x. 240 is equal to 20x. Divide by 20. We end up with x is equal to 12. So that means this side is 12. But again, the good news is you could do this whole problem over again, the same process, to try to find this side if it's different. But since they're both the same, they're both 16, then this one also has to be the same. So those sides are 12. Jacob bought 3 bulbs of elephant garlic for $5. How many bulbs could he buy if he has $12 to spend? So, 3 bulbs, we'll put bulbs on top and money on bottom for $5. And he has $12 to spend. So cross multiply, 3 times 12 is equal to 5 times x. Now I bet this isn't going to work out nice and evenly, so I'll tell you what to do here in a second. So we have 36 divided by 5. So this means he can buy 7.2 bulbs. Well, you can't buy 7.2 bulbs. So instead of just rounding with story problems, let's think of it this way. So if it's 7.2, you can't buy 0.2 of a thing of garlic. So you can either round up to 8 or round down to 7. Well, if we round up to 8, we cannot afford that. I wish you could do that. Go to Walmart and say, well, I can afford 5.3 of these, so you can just bump that up to 6 and let me buy 6. No, if you don't have enough money, you can't pay for an extra. You're just going to have to settle with 7. And again, since you can't buy 0.2 of a bulb, that's where you're going to have to stop. So that was a little bit longer, but we got a lot of different examples in there. If you have any questions, let me know.